Welcome to this explainer. Today we're going to do something a bit radical. We are going to completely dismantle your preconceived everyday assumptions about one of the most famous mathematical constants in human history. You know it, you've used it in school, you've used it in engineering, and you probably even have a few digits of it memorized. But I'm here to show you that the way we fundamentally think about pi is entirely flawed. It's really not what you think it is.
Right, so let's dive into this by calling out something we literally all do. We blindly recite formulas like c equals 2 pi r or c equals pi d. And when we do that, we're treating the radius, the number 2, and pi as if they're all the exact same kind of mathematical object. We just multiply them together without a second thought. But the moment we do that, we're making a massive fundamental error. We immediately conflate three completely distinct mathematical concepts: ratio, measure, and magnitude.
To understand the true reality of pi, we absolutely have to unblur the lines between these three concepts: ratio, measure, and magnitude. They are completely not interchangeable, even though our high school math classes basically swept them all into the exact same bucket. If we want to truly understand what's happening when we measure a circle, we have to pull these ideas apart and look at them individually.
Let's start with magnitude. We've got to recognize that the circumference, the distance around the circle, and the diameter, the distance across it, are magnitudes. In geometry, a magnitude is a physical extent. It's a real-world length. Now, pi is fundamentally different. Pi is simply what you get when one of those physical lengths is measured against the other. It is a relationship, not a physical distance itself.
So the absolutely crucial point here is that when we write c equals pi times d, what we're actually saying is that pi is c divided by d. Pi is merely an attempted measure of the ratio between the circumference and the diameter. And because of this, pi can never be the actual physical length of the circumference itself. The circumference stays a length, and pi stays an attempted measure of a ratio. Well, if it's so clear when we spell it out like that, why do we all get it so wrong? This brings us to a really fascinating logical sleight of hand. There's this invisible villain in our basic equations that tricks our brains into giving pi a false physical identity. It's a trap hidden perfectly inside the very way we simplify math. Here's exactly how the trap springs on us. Step 1. Imagine a circle where the diameter is exactly 1 unit. Step 2. You plug that into your formula. The circumference equals pi times 1. Because multiplying by the unit 1 doesn't visibly change anything in the equation, the circumference and pi suddenly look like they magically coincide. Step 3 is the trap springing shut. We mistake this invisible algebraic work for an actual identity. And this brilliantly illustrates exactly where the false idea of pi acting as a physical standalone magnitude comes from. Just because c equals pi when the diameter is 1 absolutely does not mean c is pi. The circumference remains a physical length in the real world. Pi remains the attempted measure. That unit of 1 is just hiding in the background, completely masking the difference between a physical length and a ratio. But obviously, this naturally raises a massive question, right? If we accept that pi is strictly not a physical magnitude, we have to ask ourselves why this value seems to stay exactly the same no matter what circle we measure. Whether it's a circle the size of a coin or a circle the size of a galaxy, the value we call pi never fluctuates. How is that even possible if it's not a standalone thing?
The answer requires a total shift in our perspective. We have to stop looking at isolated things, like a single physical circle, and start looking at mathematical relationships. The secret to pi's constancy isn't found in some physical object. It's found entirely in the rules of relation.
First, we just have to accept the hard truth. There is no unique magnitude pi. There's no privileged magical circle floating out there in the universe whose circumference is perfectly and uniquely pi. Every single circle you will ever draw or measure has a uniquely different circumference and a uniquely different diameter. Magnitudes are never constant across distinct circles.
So the mystery of this constant value is actually solved by Thales' proportionality theorem. This theorem dictates that all circles are geometrically similar, and because they're similar, the ratio of the circumference to the diameter in one circle perfectly equals that ratio in every other circle. The constancy we observe belongs entirely to the relation, to the ratio itself, and never to the related physical terms. So because magnitudes change but pi stays constant, pi simply cannot be a magnitude.
Okay, so we've proven mathematically that pi is not a magnitude, but get ready for an even bigger twist. If you thought pi was just a very long, highly specific number, think again. It's actually not a completed number either.
We really need to contrast two very different concepts here. First, we have completed numbers in the strict sense, numbers like 2, 3, or even 3/4. These name a measure that has actually been obtained and completed. Compare that to the concept of incommensurability. In geometry, when two lengths are incommensurable, it means absolutely no common measure exists between them. And because they share no common measure, the act of measuring one against the other simply cannot stop. It literally never terminates.
And that is exactly what happens with a circle. The circumference and the diameter are fundamentally incommensurable. Because there's no common measure for both, measuring their ratio never completes. It just keeps approximating forever and ever. Therefore, pi is really just a perpetual attempt. It's the name for an endless failed process of measurement, not the name of a completed number.
So, having completely broken down the illusion of magnitude and the illusion of completed numbers, we can finally reconstruct a definitive, structurally sound understanding of this deeply misunderstood concept. We can finally look at pi for what it actually is, totally stripped of all our bad habits.
To summarize what pi actually is, it's simply a constant name. It's the title we give to an unending approximation of an invariant ratio's measure. And crucially, its invariance, its unchanging nature, is guaranteed purely by the geometric similarity of all circles, absolutely not by the existence of an actual standalone number or a physical magnitude called pi.
Let that mind-bending reality really sink in for a second as we wrap up. Every time you calculate the area of a circle, every single time you use pi in an equation, you're not using a physical length, and you're not even using a completed, defined number. You are invoking the name of an endless, unfinishable mathematical relationship. It really makes you wonder, what other mathematical constants are we completely misunderstanding?